Then for step 5, it says here that we need to solve for ay. So how can we determine the value of ay? It says that by letting our derivative of f with respect to y, partial derivative of respect to y, equal to n. Okay, so we have partial derivative of f y is equal to n, wherein our partial derivative of f with respect to y is this part, right? So we have negative x plus a prime of y is equal to our n. What is our n? So going back, our n is 6y minus x, right? This is our n, 6y minus x. So we have 6y minus 6y minus x. Okay, once again, this is our partial derivative of f with respect to y, and our n is 6y minus x. Okay, we equate those two. By equating that, as you can see here, we can now solve for the value of our ay, wherein our a prime of y. So we have a prime of y is just, as you can see here, if we move this on the other side, it became positive x. So negative x plus positive x is just 0. This is 0. So what we've left here is a prime of y, 6y. So the value of our a prime of y is just 6y. Then we need to integrate the a prime of y. Number 6, we need to integrate a prime of y to solve for the ay, and then substitute the value of ay to step 3. So we need to integrate this. A prime of y is equal to 6y. So we need integral of 6y. It's just integral of 6y I. This is the integral of the integral of 6y. We have 6y squared all over 2, or 6 divided 2, we have 3y squared. So this is, so the integral of this, if we take the integral of this a prime of y, we can now determine the value of our ay. Okay, since this is in the first derivative, this is in form of derivative, then if we take the antiderivative, then we have here the ay only. Okay, the integral of a prime of y is ay. So this answer here is our ay. Okay, and then we need to substitute the value of our ay to step 3. So our ay is 3y squared. So we need to substitute it to our value in step 3. So this is our step 3. Let's rewrite it. So we have our value is 2x squared minus xy plus our ay, right? And by substituting the value of ay, which is equal to 3y squared, then our solution for the given DE is 2x squared minus xy plus our ay is 3y squared. Okay, yan. So this is now our general solution for the given differential equation. So once again, if we have this kind of differential equation, and let's say we now determine which is m and which is n, like what I have said, the m is the one that is multiplied by dx and n is the one that is multiplied by dy. And by checking, we need to test if this is exact by doing the partial derivative of m with respect to y and partial derivative of n with respect to x. And if the two have an exact value, the same value, yields the same value, then the given differential equation is exact. And if we prove that this is exact, we perform this. We integrate m dx, we integrate this m dx. By integrating this, we have this function plus ay. And then, after integrating, we do the opposite. We do the differential with respect to y naman. So, integrating and then differentiating this, it yields this part, negative x plus a prime of y. And then, we solve for a prime of y by equating this to n. So, as you can see, we integrate this part and then we take the partial derivative with respect to y of this part and then we equate that answer to n, to this other side, to n. So we can now have the value of our a prime of y. Then to determine the value of a prime of y, we integrate again. Okay, the integral of this a prime, of course, we will have a y once again. So the integral of this with respect to y is just 3y squared. And then going back to our equation 3, this is our equation 3. Since we have now our value of ay, we can now substitute this in our solution. So finally, we can now have our general solution, 2x squared minus xy plus 3y squared.